Hey guys, welcome back. We are on 4.8, Earth's Geography and Climate. Our learning objectives for today are to describe the Earth's climate and how it affects weather and climate in individual regions, and then understand the rain shadow effect. So first we need to understand the differences between how land and water heat. So we know that the sun provides heat energy to all surfaces of the planet, but we know that land tends to be much warmer than water does on average. So land has what we call low specific heat. So low specific heat just means that the amount of energy it takes to raise the temperature by 1 degree is low. So when the sun hits land, it tends to rise in temperature very quickly. So one of the reasons that this is true is because there's a lack of motility or movement of soil. Soil doesn't move around, it just sits there. So when the sun hits it and it warms up, that whole area tends to increase in temperature. Whereas water has a really high specific heat capacity. So the amount of energy it takes to raise the temperature by 1 degree is high. This is largely due to the motility of water. So surface water is constantly mixing with deep ocean water, which tends to be much cooler than ocean water. So the relative temperature of the ocean tends to be much cooler because it's constantly moving, and it requires much more energy to heat up. So as a result, land tends to be warmer, water tends to be cooler. Now we do sort of have this sweet spot, and these are coastal regions where the ocean meets the land. So we live in a coastal region here. The cool temperature and high specific heat of water generally tends to help keep coastal regions much cooler. So you get the cool temperatures rolling off the oceans starting to affect the relative temperatures of the land in that area as well. That's why people tend to prefer to live closer to coastal regions. But we're going to focus on that a little bit later in this PowerPoint. We are really going to talk about ocean currents today and how ocean currents play a role in relative temperatures of the planet and what actually drives ocean currents. So we're going to talk about two different types of ocean currents. There's surface ocean currents and deep ocean currents. But all movement of water or movement of the ocean is really important because it moves warm and cold waters to different parts of the globe, and those warm and cold waters are going to affect the relative land temperatures that those warm and cold waters are traveling to. So just to give you a quick example of that, the Gulf Stream is warm water that comes from the Gulf of Mexico, and it warms the east coast of the United States. Without this warm water current coming from the Gulf of Mexico up the east coast of the U.S., the left side or the east coast of the United States would be much colder than it normally is. Because of this increase in temperature, this tends to affect the primary productivity found in ocean regions, because we know that warmer temperatures tend to mean more primary productivity because more things are able to live there. So we sort of depend on these ocean currents to actually provide us with a climate that is more productive. So what actually drives these ocean currents? They're going to be driven by 5 sort of big categories. I'm going to break them down further after this: is gravity, temperature, prevailing winds, the Coriolis effect, and the location of those continents, meaning their points of latitude on the globe. So first let's talk about warm water. And so this is really going to be kind of a little bit with gravity and temperature. So this is going to be 1 and 2. So water near the equator tends to be much warmer. We know that warmer water tends to expand. It takes up much more room. The expansion of this water actually makes the water level higher. So as that warm water expands, the ocean level actually rises. In fact, it's about 3 inches higher than mid-latitude waters and even higher than polar waters. So basically what that means is we actually have this slight slope on our water levels, meaning nearest the equator, the ocean level is here, and nearer the poles, the ocean level is much lower. So this is actually one of the big driving forces that starts the process of global water circulation. This slight slope that exists combined with gravity basically forces this water to want to travel downward. So it wants to travel towards the lower water level, which means it's going to be traveling to colder regions. And we're going to take a look at where that traveling starts. But it is the first reason why we start to see global ocean circulation. Now, let's take a look at surface water circulation. Surface water circulation is largely impacted by prevailing wind patterns, and prevailing wind patterns are largely impacted by the Coriolis effect. We talked about prevailing wind patterns in class the other day. So this affects the relative movement of wind patterns. Now, surface ocean movement generally creates something called gyres, and so the water sitting on the surface is going to move in the direction that prevailing wind patterns are moving in. So you can see here in the northern hemisphere that we are moving in a clockwise direction, or our gyres are moving in a clockwise direction, but in the southern hemisphere, our gyres are moving in a counterclockwise direction. So surface ocean gyres, or surface water movement in the form of a gyre, is really important because it tends to redistribute surface ocean temperatures, or it redistributes heat. So these are sort of like convection currents in the ocean. So we kind of have talked about three different types of convection currents. We've talked about convection currents in the atmosphere, we've talked about convection currents in the lithosphere, and now we're talking about oceanic convection currents as they redistribute heat to different continents as we move from warmer areas to cooler areas. This movement of surface water actually contributes to this concept called upwelling as well, and I'll focus on this a little bit later, but basically as water gets pushed away from these coastlines, it allows for deep ocean water to make its way closer to the surface. This is a phenomena called upwelling. Upwelling is really important to the west coast of many continents. You'll notice it's happening on the west coast of most of them because that deep ocean water is where most nutrients are held. So if you think about it, when ocean organisms die, all those nutrients that are stored within them generally sink to the bottom. Those nutrients are really important to nutrient cycling. So when we have surface ocean currents pushing away from the west coast of continents, it allows for deep ocean water to make its way to the surface and bring some of those nutrients with them, which is why you tend to see higher levels of primary productivity here because you have more nutrients making their way to the surface, making more things able to survive. I guess I had a slide on upwelling here, but when we see those surface waters being pushed away due to prevailing winds moving in the direction that the Coriolis effect supports, we have these deep ocean water currents that are able to make their way towards the surface, and with that they bring up this super nutrient rich water, and that's going to be really important to the primary productivity of that area. Generally, the west coast of most continents have a really high important fishing industries because they live in an area where there's a lot of upwelling. There tends to be more primary productivity, and so fishing, large-scale fishing, becomes really important in those areas. Now, just keep in mind, we are talking about two different types of ocean water movement. We're talking about surface ocean movement, these are just gyres, and then we're also talking about deep ocean water movement. And what drives surface ocean water movement is different than what drives deep ocean water movement. The surface water is driven by prevailing winds, and the deep ocean water movement is driven by something called thermohaline circulation, which is what we're going to talk about right now. So, thermohaline circulation is sometimes also called the Great Ocean Conveyor Belt because it moves water from one ocean all the way around the planet so that it hits basically every ocean. So it is kind of like this giant conveyor belt that keeps moving. What's really interesting about this is it takes hundreds of years for water that started, say, here to make it all the way back to here as it goes through this entire conveyor belt. So it's a really, really long process. We actually talked about what initially drives this. So remember here we said that we've got this warm water current that's coming up from the Gulf Coast up the Atlantic Ocean on the east coast of the United States. This warm ocean current is actually what drives the start of thermohaline circulation. And so what is happening with thermohaline circulation is we're mixing warm surface waters with deep, colder ocean waters and allowing those nutrients from down below to make their way to the surface. So remember I talked about gravity and this slight slope that's created here when we have much warmer, less dense water. That water wants to travel downward. It wants to travel down the slope. So we see happening at one, warm water from the Gulf of Mexico to the Atlantic where it wants to start moving towards the poles. When it's here, by the way, we see high amounts of evaporation occurring. So high amounts of evaporation from this warm water leaves behind really salty water. It also leaves behind much colder water. All the warm water evaporates, the salt gets left behind, and we're left with a much colder water. Sorry about that. That water that remains is now much saltier, it's much denser, and it wants to sink to the bottom of the ocean, which is what you're seeing happening here. This water is very cold, it's very dense, it's very salty, and it wants to sink. So right now we see this ocean water moving, and it's very, very cold, and it's only traveling along the bottom of the ocean. Then that cold water, as it travels, is connecting a lot of our world's oceans. Eventually, that cold water will make its way to a warmer region, and it will rise to the surface and circulate back to the North Atlantic. That exchange that occurs, so here at like 0.4 or maybe 0.4 here, depending on the direction that it takes, is as we get closer to the equator, and as we see interactions with surface ocean currents, so places where things like upwelling occur. So this is called the Great Ocean Conveyor Belt, or thermohaline circulation. Really important for bringing cold water nutrients up to the surface, or deep water nutrients up to the surface, and really important for bringing warmer water to what would normally be colder regions, because you can imagine up here, this region should be relatively cold, but because we have this warm, shallow current making its way, it makes this landmass actually much warmer. And that's actually what I want to show you here. So notice here we've got Canada, the upper portion of the northern portion of Canada, the northeastern portion of Canada, and over here we have England. Now here's that Gulf Stream current that we talked about that comes up the coast of the east coast of the United States, and it brings this warm current. Now notice that this upper northeastern portion of Canada is at the exact same latitude that England is. The really crazy thing, even though these are the exact same latitude and you would expect them to have almost identical climates, England actually tends to be much warmer than Canada does, because this North Atlantic current actually comes and brings warm water here, whereas this Canada area has this cold water current that makes its way through its coast, and it actually is much colder. So even though they are at the same point of latitude, they are receiving different warm and cold ocean currents, and it directly impacts the relative temperature of the land, which is kind of what we were talking about on the first slide. Okay, and this is the last big idea. It's a little different than what we were talking about, but it does have to do with prevailing winds coming off of the ocean. That's something called the rain shadow effect. So the rain shadow effect is really interesting. So you'll notice that you have this mountain range, and we've got something called the windward side and the leeward side. The windward side is going to be the wind-facing side of the mountain, where we get all of this warm, moist air that makes its way towards the mountain. It tends to be much wetter, whereas the leeward side of the island tends to be very cold and dry. So what you're seeing happening here is a prevailing wind coming off of an ocean. As this prevailing wind is coming off of the coast of this ocean, it's picking up water. It's creating it's evaporating water off of the ocean. So what you get is this very warm, very humid, very moist prevailing wind, that as that starts to rise over this mountain range, you get precipitation because it reaches this point of saturation and you get tons and tons of precipitation. And then as that prevailing wind makes its way to the other side of the mountain, where there is no evaporation and there is no ocean, the leeward side of the mountain, it starts to drop as very cold, dry air and pick up this much warmer, dry current. So you'll notice on this side of the mountain, we're very lush, very green. We receive a lot of precipitation. We're a very moderate temperature, whereas this side of the mountain is going to be much colder, much drier, until we get to the bottom of it, where it's just going to be very hot and dry. This is exactly what we see here in Orange County, where Our coastal regions are much greener. They receive a little bit more precipitation, but just on the other side of our hills, we have almost a desert that is very dry and can be very cold or very hot, depending on the time of year. So if you're looking for the steps that I just talked about, they're listed here on this slide. But I think that's it for today. If you have questions about ocean circulation or the rain shadow effect, let's talk more in class. I'll see you then. Thanks.